This video is for topic 6.5 over parallel and perpendicular lines when given a graph. So we are asked to graph the following lines in the grids provided, and we are reminded that in order to graph, we must have them in slope-intercept or y equals mx plus b form. So the first one, we have y equals 3x plus 5 and y plus 4 equals 3x. So this one is good to go. I can immediately identify my slope and my y-intercept. But the second one we have to rearrange because we don't know what y equals. We know what y plus 4 equals. So we move the 4 to the other side and we rewrite y equals 3x minus 4. Now I can see what my slope and y-intercept would be. I plot them on a graph. So the first one I go up to 5 on the y-axis, up 3, right 1. The second one I go down 4 on the y-axis, up 3, right 1. I can see based on the graph that these lines are parallel because they have the same slope. So I see on the graph that they are parallel. I remember that parallel means they have the same slope. For problem 2, both of these have to be solved for y in some form or fashion. And so on the first one, we move x to the other side and then divide everything by 3, and we get negative 1/3 x minus 2. The second one, we just have to divide by 3, and we get positive 1/3 x minus 2. So these both start at the same y-intercept. One goes up and right 3, one goes down 1 and right 3. Because these slopes are not exactly the same or complete opposites, these are neither. They cross, but they do not cross at 90-degree angles, so I can't say that they're perpendicular. So this just means that they cross, and because they cross, they're not going to be parallel. So problem 3, this one is already solved for y. If y being on the other side confuses you, you can rewrite it, but y is already by itself. So we can easily identify that our slope is with x and our y-intercept follows. So 2 for the slope and 1 for the b value. So for this one, we're going to have to solve for y. I move x to the other side through the opposite operation. So I'm left with 2y equals negative x plus 8. And I remind myself that x and 8 are not like terms, so I cannot combine them. I then have to divide every piece by 2. So y equals negative 1/2 x plus 4. So my slope with x is negative 1/2, and my b value is 4. Now before I put them on a graph, looking only at my slopes, I can see that these are going to be perpendicular because they are complete opposites. Or opposite reciprocals, you could also say, because they flop, flipped in opposites. So my green line starts up at 1. And goes up 2, right 1, up 2, right 1, up 2, right 1. Also down 2, left 1. And then the red line starts up at 4 and goes down 1, right 2. Down 1, right 2. We can also go up 1, left 2. And I'm not the best line drawer, but we can see right here, these look like they cross about at a T, if we turn our heads. Whereas example 2 crosses, but is not like a perfect T. So that's where the difference comes in between just crossing because my slopes are not perpendicular and crossing exactly because my slopes are perpendicular. So problem 4 asks us for a line that is parallel to the x-axis that goes through the point negative 7, 8. So what I did is I went to the point negative 7, 8 up here, and I drew a line parallel to the x-axis. So parallel to the x-axis will go through the y-axis. This line I've labeled A has a slope of 0 and is the equation y equals 8 because it has a slope of 0. It is a HOI, and therefore y equals my y point. The point 2, 3 I have plotted here for line B. It is perpendicular to the x-axis, meaning it goes through the x-axis. This is a vertical line, so it is a BUX. And it has an undefined slope, and it is x equals my x point. So problem 5, we're going to do something similar. So I have the point negative 7, 8, and they want it to be parallel to the y-axis. So I go up to the point negative 7, 8. Parallel to the y-axis means they look exactly the same. They're never, ever, ever going to cross. This is a vertical line, so it will be a vux. After I've drawn the line, I can see it will be a vux. Slope of a vux is undefined, and my equation is x equals my x point. B wants something perpendicular going through 2, 3. They want it perpendicular to the y-axis, meaning it makes a T with the y-axis. So it has to go through the y-axis, meaning it will be a HOI. The slope of a HOI is 0, and the equation is y equals my y point of 3. So again, the best thing you can do is plot the point, draw what they're asking for, and then figure out, did I draw a vux or a HOI, to answer the rest of your questions. Problem 6 asks us for a line parallel to that graph and passes through the new point, negative 3, 5. So parallel keeps the same slope, so my slope is 2, 3. I have a point and a slope, so I put it in point slope form. Y minus my y point equals mx minus my x point. Remember, minus minus turns it into a plus. I distribute 2/3 times x, 2/3 times 3, and then move 5 to the other side for a total y-intercept of 7. I can double check very quickly. Parallel would have the same slope, so I started with 2/3. My new equation has 2/3, so I did not mess that up. Again, parallel, in order to find out what my slope would be, I need to solve for y, so y equals 5x minus 2. My slope, parallel means same. So my new slope is going to be 5, and my new point is 2, negative 1. So I plug in 2-point slope, y minus my y point. Minus minus turns that negative 1 into a plus. M is 5, x minus my x point of 2, and I close my parentheses. So again, my point has changed. 2 turns into negative 2, negative 1 turns into positive 1. From here, we distribute 5 times x, 5 times negative 2. Subtract 1 from both sides. Y equals 5x minus 11. Problem 6, we have the beginning part of it. We don't have the whole thing. They ask us for a line that is perpendicular to that line. Remember, perpendicular has a flipped or a flopped slope, so it's a complete opposite. 2, positive 2, turns into a negative 1/2, and then the point was given to me. So y minus my y point equals m x minus my x point. And again, both of these started negative, so they will be written in as positives because minus means change the sign. I distribute negative 1/2 times x, negative 1/2 of 2. Add 6 to both number sides. And y equals negative 1/2 x plus 5. So again, parallel and perpendicular, the only piece that's different is the slope. You still plug in 2-point slope form. You still solve the exact same way by getting y by itself. So keep that in mind. The only thing that varies or changes is what you do with the slope from the original equation.